Cycle of illness, immune system, part 3. Welcome to part 3 of the cycle of illness, the immune system, and the microbiome. If you've been following along with the cycle of illness series, you have heard me keep saying, how is it all connected? Well, guess what? This is where we answer that question. The microbiome doesn't just sit quietly in the gut. It talks to every major system in the body through what we call the gut organ axis. These axes link the gut to the brain, the skin, the lungs, the heart, the liver, the pancreas, the kidneys, the muscles, the bones, even our hormones and metabolism. When the microbiome is out of balance, all of these systems work together to support health. But when it shifts into dysbiosis, an imbalance between the good and bad bacteria, that's when inflammation, dysfunction, and chronic illness begins to ripple through the body, locking us into what I call the cycle of illness. On the left, you can see how dysbiosis is connected to conditions like asthma, diabetes, heart disease, psychiatric disorders, and so much more. And on the right, you can see a map where different bacterial strains live along the digestive tract, from the stomach to the small intestine to the colon, and how each community influences different organs and systems. Because this is such a wide topic, we'll take it step by step. Each axis is going to get its own mini video showing exactly how the microbiome shapes that system, and how it ties back into the cycle of illness. This is where it all comes together. This is how I show you how it all connects. This is the big picture, the big grand finale. And yes, I will have a mic drop at the end.
What do you say to that? What do you say to that? And 1 second to exit stage right.
You've heard me say that the microbiome is the linchpin to the cycle of illness. So let's zoom in and see what this really looks like. Think of the microbiome as the hub of a wheel. From that hub, spokes reach out to nearly every system in the body. On the left, you see the main systems we're going to be covering: the digestive tract, mitochondria and energy, the immune and nervous system, the endocrine system that drives the metabolisms, hormones, fertility, mood, sleep. We'll also look at its role in inflammation, cardiac health, allergies, and mast cell activity. And I haven't prepared these next sections quite yet, but we'll be adding lung, liver, pancreas, skin, kidney, and muscle down the road. This is an ever-evolving project, and there will always be more things to discuss or to add. So in part 3, you can see we're going to be discussing the microbiome and the digestive system, which also includes salicylates and oxalates, mitochondrial health, immune system, nervous system, which encompasses the gut-brain axis, and the HPA axis, which is your stress response system, your endocrine system, which encompasses your metabolism, the belly fat, energy metabolism, blood sugar control, growth and development, sex hormones, fertility and reproduction, sleep cycles, mood regulation, bone health, hydration, blood pressure, neuroendocrine immune axis, which we'll discuss the difference between the neuroendocrine immune axis and the neuroimmune axis, the adrenal hormones, along with catecholamines, aldosterone, cortisol, DHEA, and norepinephrine. And there are 3 prime axes of the endocrine system. There's the HPT, which is the hypothalamus pituitary thyroid axis, the HPG, which is the hypothalamus pituitary gonads, and the HPA, the hypothalamus pituitary adrenal glands. And what happens when your endocrine system has dysbiosis and dysregulation. We'll also be discussing the microbiome and hormones, and this encompasses estrogen, thyroid, and blood sugar. We will also be looking at the microbiome and methylation, which makes biopterin, which is BH4, and how your microbiome affects the folate receptors in your body. So if you have the MTHFR gene mutations, you're going to want to understand this, as well as the microbiome and inflammation, cardiac health, food allergies, and mast cells. And like I said, there will always be more sections to add down the road. And on the right, you can see the gut organ axes. Those pathways where gut imbalance connects directly to the disease in brain, heart, lungs, liver, kidney, skin, reproductive system, and more. This is a ripple effect. When the hub is strong, the wheels turn smoothly. But when the hub is damaged, Every spoke feels the strain, and that's how the microbiome drives the cycle of illness. So let's look at how the microbiome affects digestion. The human gastrointestinal tract is home to a complex and dynamic community of microorganisms, and we learned that in part 2, and collectively known as the gut microbiome. These microorganisms play a fundamental role in the digestive process, contributing to the breakdown of food components, absorption of nutrients, and overall gastrointestinal health. The gut microbiome plays an essential role in the digestion and overall health of the host. By breaking down complex carbohydrates, proteins, lipids, and synthesizing essential vitamins and modulating immune responses, the microbiome contributes significantly to nutritional absorption, metabolic regulation, and immune function. Understanding the interactions between the gut microbiome and the digestive processes can lead to new therapeutic approaches for managing digestive disorders and promoting overall health. Beneficial microbes in your gut help train your immune system to tell the difference between what is you and what is foreign. And if you remember, we talked about this in part 1 with the B cells and the T cells. Your gut is the largest immune system organ, containing up to 80% of your body's immune cells. They aid in digestion and nutrient absorption, like B vitamins, K, and we talked about this earlier. It also provides enzymes to necessarily synthesize certain vitamins, such as B1, B9, B12, and K. These may seem like small nutrients, but micronutrient deficiencies have a huge impact on your health. And we learned in the previous videos that B12 deficiency, folate deficiency, and vitamin K deficiency has a huge impact on our overall health, as well as vitamin D. Without these, our system, especially methylation, will drastically slow and eventually come to a halt if not corrected. And the bacteria in your gut help break down complex carbohydrates, proteins, lipids, and dietary fibers. Believe it or not, you can't break them down on your own. You need the gut microbiome to help you do that. And they produce short-chain fatty acids to do it. Short-chain fatty acids are the byproducts of helpful bacteria that support your immune system. They maintain gut barrier. It keeps the bacteria and bacterial toxins inside from escaping into your bloodstream. They also have anti-inflammatory properties for your gut. Short-chain fatty acids, like butyrate in particular, feed the cells in your gut lining and help to keep your overall gut environment healthy. Butyrate also helps with IBS, and as we had talked in a previous video, it also helps stabilize the heart rhythm. Gut bacteria also helps to metabolize bile in your intestines. This is actually really important. Your liver sends bile to your small intestines to help you digest fats. The bile also helps keep your intestinal tract free of parasites, overgrowths, and infections. When it's done, bacteria and their enzymes help break down so that the bile acids can be reabsorbed and recycled back into the liver. It's called enterohepatic circulation. If this process stopped working, your body would be unable to recycle bile acids, and your liver wouldn't have enough to produce new bile, which means that your digestive system wouldn't get the bile it needs to digest and absorb fats. Leftover cholesterol, one of the components of bile, would build up in your blood. If you have inherited methylation issues, this is automatically going to affect your digestion, which means it affects your pancreas, your gallbladder, and your liver. And this will create an improper microbiome. So you're already starting behind the curve. Okay, so we already said that the gut bacteria also helps to metabolize bile in your intestines. Your liver is sending the bile to your gallbladder, which then goes to small intestine to help you digest fats. And then when it's done, bacteria and their enzymes help to break it down so that the bile acids can be reabsorbed and recycled by your liver. Remember, it's the enterohepatic circulation. Now, if you do not have a proper microbiome, as we have been discussing, we can't do this. And that means the bile builds up and it's not getting recycled. So if it doesn't get recycled, that means the next time you eat, you don't have enough bile to digest your food again. And if that's the case, then you can't absorb fats. And this is why a lot of folks have to start taking a digestive aid like pancreatine, because this process isn't working properly because you just don't have enough bile to digest your food every time you eat. And like I said, if you already have methylation impairments, this is already hampered. Alright, and to add insult to injury, this buildup of bile also means extra cholesterol from the liver, which we said that, hey, this is going to cause more skin tags. But the bile also starts to talk to your brain, and it can start making metabolic changes in your body. And as we've been saying through the entire Cycle of Illness series, these are not good changes. It's affecting your entire cycle of illness. Now, if you have methylation impairments and you add stress on top of this right here will crash this whole process. And this is where you start getting infections, bacterial overgrowths, parasites, and toxin buildup inside of your gut. Now, leftover cholesterol is one of the components of bile, and this would build up in your blood. So, the bile also talks to your brain, which can also start making some metabolic changes. And the body starts stashing every toxin it can't immediately metabolize and detox from your body. It will start to store it in muscle, fat, and cells. This creates a whole chain reaction and a vicious cycle. So if your body is starting to store toxins in your muscle, fat, and cells because it can't metabolize it or detox it or break it down, you start getting abdominal fat, which is that adipose tissue, the bad white adipose belly fat. And it starts to act like an endocrine organ, and it starts pumping out more hormones and releases a protein that tells your body to start creating even more inflammation. This will start a whole cascade of a vicious cycle and make all of your symptoms worse. Now, sometimes you're just born with methylation impairments and there's not a whole lot you can do. You can help support it, but there's only so much you can do. But if you're adding stress on top of that, you're causing an immune response. You may be losing weight, and by supporting your methylation cycles and supporting your gallbladder with things like choline, the pancreas, by using pancreatine to help your body digest fats, proteins, and carbohydrates, and primal earth probiotics. So this whole process also helps with maintaining proper gut microbiome as well. So, and it helps to keep you healthy. So you can see how important stress, methylation issues already kind of put you at a deficit and weaken your microbiome. And this, believe it or not, a buildup of cholesterol causes skin tags. If you have methylation impairment, difficulty detoxing non-alcoholic fatty liver, this will slow down this process and create health issues and possibly gallbladder pain. So this is a major contributing factor as to why many of us have gallbladder pain and microbiomes that can give us a run for our money symptom-wise. This is where you can get into a vicious cycle. And believe it or not, you can start with vicious cycle number 1 and switch to vicious cycle number 2. If this happens, it's a giant red warning flag. So please take this seriously and cut down your toxins, triggers, and stress load. Whether it's caused by dysbiosis, SIBO, candida, leaky gut, mold, methylation impairments, or poor high diet in fats and sugar, and even caffeine, etc., you can get into one of these two problems. Both are telling you something important for you to take notice. The body is asking or begging for help. With methylation impairments, as we've already shown, it affects your liver, gallbladder, and pancreas. And if your microbiome is weak, you will not be recycling enough bile, and you're going to need pancreatine or some other type of digestive aid to help you break down food. With a weak microbiome, this becomes tougher and tougher to do. And remember, methylation impairments, gut dysbiosis, SIBO, candida, and even stress can play a huge impact on this. These are the two vicious cycles that can emerge, And believe it or not, these vicious cycles play a great deal in autoimmunity and chronic activation of it, neurological symptoms, and mast cell conditions, and causes more of it. This is what gets you trapped. All right, vicious cycle number 1. You can gain weight. You wind up storing toxins in the body and can't detox due to methylation or gallbladder impairments and or gut dysbiosis, leaky gut, in conjunction with methylation and gallbladder issues. Now, the gaining weight can go hand in hand with inflammation. Sometimes it can be difficult to tell the difference between weight gained or inflammation. But when you really start packing it on, then you know that you're gaining weight and that is also increasing more inflammation. This will cause weaker biomes, insulin resistance, and worsening autoimmunity. This creates white adipose tissue, and that's the unhealthy white fat, belly fat that we have talked about previously in the videos. And the toxins get stashed in the muscle as well, as a self-preservation method to prevent the body from getting into crisis. The body will begin the detox process when it is out of fight or flight, fasting, or dietary changes. So if your body is putting on additional weight, what's happening is your body is trying to tell you, oh, hey, it's too much, we can't handle it, and it's preventing you from going into crisis mode where you need an ambulance or a hospital. This is one of your body's self-preservation methods, so take this seriously. The body will need a break in order to deal with all those toxins it's been stashing into your belly fat or other fat throughout your body and in your muscles. It is also going to be important for your bile recycling to be working. And we talked about the enterohepatic circulation. And if you are in this phase, you will most likely require pancreatine if it's not working properly. One other telltale sign that your liver is struggling is the fact that your cholesterol is going to start climbing. And when that happens, your body is going to start producing a lot of skin tags. That is a telltale sign. Another point of information you need to have is the fact that the more body fat that you accumulate, the more inflammation it's going to tell your body to make. And eventually that belly fat turns into an endocrine organ, or it acts like an endocrine organ. And this further tells your body to make more inflammation. And on top of that, it also starts messing with your hormones. And the more your hormones and inflammation get messed with, the harder it is to get out of this vicious cycle. Now, if you're in this part of the cycle, fasting can get you out of it. These are all very big warning signs for option number 1. Option number 2, and believe it or not, you can switch from option number 1 to option number 2. You wind up starting to lose weight, and you start losing it quickly. And you'll start noticing atrophy, or what is called muscle wasting. This is actually called cachexia, and mast cell patients, autoimmune patients, cancer patients can get stuck into this. This is a massive red flag. If you get stuck into this, that is your body crying for help. Please see the cachexia slides, because I made an entire section and another whole rabbit hole I had to go down to map this all out for you, because it actually plays a very important part in your overall health. And I know many autoimmune, cancer patients, and mast cell patients that do get stuck into this pattern. And please understand that there is a way out of it, but it's a little bit tricky. And if you go to the cachexia slides, it will teach you how. We will be covering this in the next video. And this is caused by chronic stress, chronic fight or flight, mast cell flares, and chronic activation and autoimmunity from triggers, fasting, too much of it, and extreme leaky gut and damaged gut. There is not enough energy reserves in the body to keep the body chronically activated. So it has to have and get its energy from somewhere, and it starts cannibalizing your muscle and fat in order to create energy for your body. When this happens, it's going to have an entire cascade effect. You're going to wind up with worsening autoimmunity because the immune confusion is going to grow due to chronic activation, more mast cell issues, If you don't already, more neurological issues and the possibility of your chronic illness turning into cancer. This can also cause further gut damage, further weakening the microbiome, damage to various systems in your body and organ damage, methylation shutdown, and most importantly, mitochondrial collapse. You do not want this, because this is a very bad place to be in. Now, I don't want you to lose hope, because you can get out of this. It can be a little tricky at first, but if you go to the cachexia slides, it'll show you there how to get out of it, and there are a couple different methods to do so. Use discernment and talk to your doctor as to which options are the safest. Now, a lot of us here have trouble getting that help from their physicians because of the fact that our conditions are so complicated, and the fact that medicine is compartmentalized and the body is not. It's all integrated. So use your discernment. Listen to your gut. Listen to your body. It will tell you what it needs. Choline and taurine can actually help gallbladder and liver pain. Choline coats the gallbladder, soothing it from the toxic soup that's inside of it. And taurine helps the liver detox. And if you have sludgy bile, it turns it back into a free-flowing viscous material that can be used to digest food, particularly fats. So your gallbladder fluid that comes out, it's supposed to be like dish soap, that type of consistency. But if you have chronic dehydration, too much sugar, etc., and you have not a healthy diet, it kind of turns more into molasses, and then it doesn't work as efficiently for you. So the choline can help protect the lining of your gallbladder if you're in pain, and then the taurine can actually help change that sludgy bile back into that viscous dish soapy like material. This will help keep your intestines clear of candida, SIBO, dysbiosis, infection, and parasites, because like I said, it helps keep your intestinal tract healthy and clean. The microbiome also helps regulate gut barrier integrity, so leaky gut equals a disrupted microbiome. This is really important to understand because it has such a cascade effect in your health and inside of your microbiome. Helpful gut microbes also compete directly with unhelpful types for real estate and nutrients, preventing them from taking up too much territory. So your good bacteria and your bad bacteria, to put it plainly, it's like they're at war with each other over who's going to win. Some chronic bacteria infections that can affect the gut that is directly related to a diminished gut and bile is C. difficile and H. pylori. Now, I know there's a lot of folks out there that suffer with this and have difficulty with it. Now, if you fix your diet and you help support your methylation and your gallbladder, you can help heal this. It also helps with your immune system as well. Inflammation is a function of your immune system, but it can malfunction and become hyperreactive. And chronic inflammation is a feature of autoimmune diseases and may have a role in many other diseases, including cancer. Short-chain fatty acids seem to suppress these types of inflammatory reactions, and that's why plant-based foods are so very much important. And a well-rounded, healthy diet is what's truly important for your health. If you can't eat anything and you're limited to almost nothing, then this whole process is not working properly and your microbiome has taken a huge hit. And remember, pre-existing methylation impairments, stress, a high sugar diet, a lack of exercise, and a leaky gut is going to cause a massive cascading effect throughout your body. So as we said, bacteria in your gut help break down complex carbohydrates, proteins, lipids, and dietary fibers. You can't break them down on your own. Your body has to produce these short-chain fatty acids to do it. Now, carbohydrate digestion. Fermentation of dietary fibers. Dietary fibers are composed of non-digestible carbohydrates, and they reach the colon where they are fermented by gut bacteria. And this is why some folks have a great deal of difficulty with their symptoms. This fermentation process produces short-chain fatty acids such as acetate, propionate, and butyrate, which serve as energy sources for colonic cells and have various beneficial effects on your gut health. But for some of us with mast cell disorders, it raises our histamine levels. Acetate, the most abundant short-chain fatty acid, acetate can be absorbed and used as energy source by peripheral tissues. It also plays a role in cholesterol metabolism and lipogenesis. Now, propionate is absorbed and transported to the liver, where it is involved in glucogenesis and inhibits cholesterol synthesis. Now, gluconeogenesis is the metabolic process of synthesizing glucose from non-carbohydrate precursors like lactate, glycerol, and certain amino acids. This process primarily occurs in the liver and in the kidneys, and it is crucial for maintaining your blood glucose levels during periods of fasting or low carbohydrate intake. Essentially, it's the body's way of making its own glucose when dietary sources are insufficient. So gluconeogenesis literally means making new glucose, or sugar. It's the body's backup plan for when you don't have enough carbs, sugar, or starch coming in from food. Instead of shutting down, your body says, no worries, I'll just build some sugar myself. And it does it by using amino acids, lactate, and glycerol that is all already in the body. This process happens mainly in the liver and to a smaller degree in the kidneys. It uses building blocks like the amino acids from protein breakdown, lactate from exercise or muscle activity, and glycerol from fat being broken down by your microbiome. By doing this, gluconeogenesis keeps your brain, your red blood cells, and vital organs fueled, even if you haven't eaten enough carbs. And the reason I'm mentioning this here is because if you have a very damaged gut, you're not going to be able to break down the food particles because of a weakened microbiome. And if your gut is really damaged, then what's going to wind up happening is the food is leaking out into your bloodstream, which is kicking you up into chronic inflammation and immune activation, which burns a lot of calories. And then this can cause issues with your blood sugars and with your weight. So think of your body as like its own little micro city, okay? Carbohydrates are regular shipments of fuel trucks delivering sugar to the power stations. But sometimes the trucks don't show up, like when you're fasting or when you're sick or during a low-carb diet. The city can't just shut down, or your body in this case, so the liver acts like an emergency factory. It takes scrap materials like protein, fat fragments, and lactate and rebuilds them into a brand new fuel called glucose. That way, the power stays on even when the regular deliveries stop. Now, to tie this back to the microbiome, propionate, which is a short-chain fatty acid produced during fermentation, can be used as raw material for gluconeogenesis. In this way, the microbiome actually donates ingredients like protein fragments, lactate, and propionate, which we have mentioned several times in this slide, to the body's backup generator. This helps regulate blood sugar and metabolism. Now, if you are not eating your fruits and vegetables and getting enough fiber, you are not going to be able to do this efficiently whatsoever. If you also have an extremely damaged gut where it's constantly leaking into your bloodstream, this is also going to cause a problem because it's ramping up your immune responses and triggering your mast cells if you happen to have a mast cell disorder. Now, the flip side to this is also if your microbiome is insufficient, it also cannot make the proper ingredients in order for this process to work. So if your microbiome has crashed or you have SIBO, Candida, etc., it can greatly affect how this process works. So gluconeogenesis isn't just a backup plan. It's a dynamic process that connects diet, liver metabolism, and the microbiome, and it directly links to blood sugar problems when this regulation goes wrong. There's a lot of us in the chronic illness department where our blood sugars swing from one end to the other, and we don't quite go into hypoglycemia or diabetes, but we swing the whole spectrum. So when this is happening, this is your body telling you, one, your microbiome is insufficient. Two, your immune system or mast cells are stuck, constantly responding, so that is going to require more fuel and you will run out. It's also a sign of an improper microbiome that cannot support proper metabolism, or it's also a sign of a poor diet. This will also contribute to your fatigue levels. It's not direct, but it is indirect. As we've already hinted, gluconeogenesis links to blood sugar problems. In healthy people, gluconeogenesis, which is the process of making new glucose or sugar, only runs when needed, such as during fasting or low carb intake or when you're sick. But in diabetes, the liver often gets the wrong signals. It keeps cranking out glucose even when the blood sugar is already high. This is like a backup generator running full blast even though the power grid is already restored, flooding the system with extra electricity, or in this case, sugar. The result is hypoglycemia or high blood sugar. On the other hand, if gluconeogenesis isn't working well, your body can't make enough sugar between meals. This causes hypoglycemia or dangerously low blood sugar crashes. Think of this as a backup generator failing to start when the lights go out. Your brain and organs suddenly don't have enough fuel. Normally, insulin acts like a brake on gluconeogenesis, telling the liver, hey, stop making glucose. We already have enough. But in insulin resistance, the liver ignores that brake pedal and keeps producing sugar. So for those of you who struggle with insulin resistance, this is what's happening. This not only raises blood sugar, it makes insulin resistance worse because the pancreas has to keep pumping out more insulin. And remember, as we've told you before, methylation impairments affect your gallbladder, your liver, and your pancreas. So this can turn into a vicious cycle. Insulin resistance leads to more gluconeogenesis, which drives higher blood sugars, which then triggers even more insulin resistance. Now, here's where the microbiome fits in. Propionate and other short-chain fatty acids made from the fiber fermentation can help fine-tune gluconeogenesis, keeping your blood sugar steady instead of letting it swing out of control. But when there's dysbiosis or a bad microbiome balance, this takes over and it worsens the cycle by feeding insulin resistance, inflammation, and blood sugar crashes or spikes. And it does not help if you are drinking sodas, junk food, carbs, etc. That will make it worse. So where does this fit into the cycle of illness framework? Too much gluconeogenesis drives hyperglycemia, diabetes, and insulin resistance. Too little gluconeogenesis drives hypoglycemia. The microbiome acts as a modulator, either keeping the balance or driving the dysfunction. Okay, fermentation in the gut. So this is all related. This is a little bit more indirect, okay? Fermentation in the gut can be a double-edged sword. Short-chain fatty acids regulate inflammation and histamine. So just like they help regulate your neoglucogenesis and blood sugars, it also helps with histamine. While dysbiosis bacteria produce biogenic amines like histamine, tyramine, protosine, and leading to MCAS flares. In a healthy microbiome, gut microbiome ferment fibers into short-chain fatty acids like acetate, propionate, and butyrate, and we've been discussing this whole time. These short-chain fatty acids calm inflammation, they stabilize those blood sugars, and they actually help regulate histamine release from mast cells. So this is generally a good fermentation. But when the microbiome is imbalanced, what we call dysbiosis, the wrong bacteria can take over. Bugs like Morganella, Klebsiella, or even certain lactobacillus strains can ferment carbs and proteins into biogenic amines like histamine, tyramine, protosine, and cadaverine. This overload spikes histamine in the body, worsening food reactions, IBS, migraines, flushing, and MCAS symptoms. This is bad fermentation. Here's why symptoms get worse with dysbiosis. A weak microbiome doesn't properly break down histamine because DAO enzyme activity in the gut lining is low. At the same time, fermentation is producing more histamine than the body can clear. It builds up in the colon, leaks into the bloodstream, and your histamine bucket, so to say, overflows. The result is inflammation and mast cell activation throughout the body. The other thing is if you have the AOC1 gene, which produces DAO in your gut, if you have a mutation in that, it's automatically going to be more difficult for you. So you have to be very careful with keeping your gut balanced. The other fact is if you have an extremely damaged gut or a leaky gut, and those fingers, the villi that moves the food through your intestinal tract, if those are badly damaged, it can't do its job properly. They also help produce DAO. And if they're damaged, they can't. So, if it works something like this, a weak microbiome allows the wrong bugs to ferment carbs and proteins, leading to more histamine production, less DAO breakdown. You wind up with a systemic overload and worsening mast cell activation and inflammation. And for those who have autoimmune conditions, the same thing, because mast cells and inflammation are going to worsen your autoimmune condition. All of this puts your microbiome even further out of balance. So in dysbiosis, colon fermentation can worsen symptoms because it fuels histamine instead of just producing those short-chain fatty acids that your body absolutely needs. But in a healthy microbiome, fermentation is your friend. It helps keep inflammation and keeps the histamine balanced. So basically, what did I all just say? Think of your gut like a kitchen. Good chefs cook healthy meals out of fiber, making fuel that calms your system. But when there's bad chefs in the kitchen, they take over, they burn the food, and fill the room with smoke. That smoke is like histamine. The more smoke, the worse your symptoms. And that's about as easy as I could try to make an analogy for that. Okay, moving on. The digestion and microbiome also is involved in protein digestion. It breaks down proteins. The gut microbiome aids in the breakdown of dietary proteins into peptides and amino acids, which are further metabolized to produce various bioactive compounds. Some gut bacteria possess proteolytic enzymes that can degrade complex proteins that the human digestive system cannot break down alone. Amino acid metabolism. Microbial fermentation of amino acids produces metabolites such as branched-chain fatty acids, phenylytic compounds, and indoles. These metabolites can influence host metabolism and immune responses. So what does that all mean for you in your chronic illness? Okay, so without a proper microbiome, protein doesn't fully disappear in the small intestines. Whatever is left reaches the colon and the microbiome gets to work. A healthy microbiome and enough fiber, the microbes mostly make short-chain fatty acids, and that's acetate, propionate, and butyrate, and this helps calm inflammation. Now, if you have a weak or damaged gut, your colon bugs ferment protein instead of processing it like it's supposed to, and this will produce ammonia from deaminating amino acids and splitting their urea, biogenic amines, which is histamine, tyramine, purine, and cadaverine, and branched-chain fatty acids and other irritants, all of which cause you symptoms, all of which cause damage. Okay, I want you to think of ammonia as like exhaust fumes on a car. Your healthy liver is a catalytic converter that runs those fumes into urea and clears them. You need a healthy urea cycle and methylation in mitochondria to do this, and with certain cofactors such as arginine, your BH4, and the nitric oxide synthase, your NOS gene. If your gut is leaky, you have dysbiosis, or you have constipation, or your liver is overworked, so your catalytic converter, if it's overworked, those fumes will back up in the body. Your fumes back up, and that means you're going to wind up with brain fog, fatigue, and headache, and more immune activation. Those amines and endotoxins, they also poke at your mast cells. If you're sensitive, this means flushing, itching, GI cramping, and lymph node pain because the immune system is gearing up. Now, you don't always have to have all of those symptoms. It's going to be slightly different for everyone. But if you are getting that lymph node pain, this is a huge, huge, huge factor. And if you're constantly getting the brain fog, headaches, fatigue, etc., this is also because your ammonia and other toxins are building up in your system. So protein, while all of this is happening, can actually wind up becoming your enemy, and you don't want that. Now, if you're already running hot with, say, an autoimmune condition or MCAS or some kind of mast cell disorder, large or poorly digested protein fragments slip out of the leaky gut barrier, and your body recognizes them as foreign. And what happens when your body recognizes a foreign object? It goes after it because it's saying, hey, we got a foe sitting in our body and we have to neutralize it. So your immune system starts to respond. So the antigen presenting cells flag them. And when they get flagged, as we've been learning throughout the entire series, your cytokines rise, mast cells start degranulating, and you will feel a temporary flare-up or reaction. This can also feel very hot to your skin and your body, and this includes tender lymph nodes after eating protein. This can also cause emotional irregulation amongst other symptoms like ugly crying, irritability, etc. So if you have a lot of protein and suddenly your mood just suddenly changes, this is part of the equation. So you can wind up with ugly crying. For those of you who just can't get up, you're completely inconsolable. This is part of the equation, and your BH4 has crashed. It can also result in brain fog, fatigue, neurological symptoms, migraines, neuroimmune activation, confusion of your immune system, lymph node pain, your B and T cell activation, and too much ammonia buildup. So the ammonia buildup is coming from the protein. If you have leaky gut, MTHFR 1298 Charlie, the NOS gene, COMT, CBS, then this makes this issue worse. Left unchecked and not healed can cause a cascade effect of worsening symptoms. And these symptoms seemingly have no root cause, but they do. Many folks out there usually wind up hearing it's all in your head, or there's no correlation between their diagnosis and those particular symptoms. If I've heard it, you've heard it. And many will be left hanging, not knowing what to do and feeling like they're not listened to. So I'm here to tell you right now, there is a reason for those symptoms. And this will further cause your gut damage, leaky gut, damage to nerves, renal, cardiac, brain, neural, and epigenetic changes, leading to more significant autoimmune disorders or serious illness. If you're getting significant lymph node pain, rapid weight loss, and muscle atrophy or wasting, this is a massive red giant flag. So please take this seriously. So, protein left in the colon will equal ammonia and bioagenic means going up. Barrier irritation and mast cell activation happens after that, and if you still don't stop the process, then you get immune confusion, which is followed by a flare-up. If you feed the fiber-loving bugs and the story flips, your short-chain fatty acids go up, your inflammation goes down, which means your mast cells start to calm, and the liver has less exhaust to clear. So, now the reason I have short-chain fatty acids flagged here or starred, you have to make sure you're getting enough in order to create short-chain fatty acids. If you're not creating short-chain fatty acids, you're not going to be able to drop that inflammation. However, sometimes to heal the gut, we have to skip this initially just to calm the gut and the immune reactions. And generally, we do this through fasting and possibly juicing, depending on your unique biochemistry. But you're starting to see why I'm always saying we have to fast and we have to juice. This is all part of that equation. And the fasting and the juicing, it bypasses all this, resets it, and rebuilds your system. So the microbiome isn't just about digestion. It is the silent guardian of all of our strength. When it's healthy, it comes and helps absorb nutrients, fuels our mitochondria with short-chain fatty acids, and calms inflammation, keeping our muscles strong and protected. But when the gut is damaged and the microbiome grows weak, everything shifts. Nutrients are going to start slipping through unabsorbed, inflammation is going to surge, and the body, desperate for energy, begins to break down its own muscles to survive. This is the beginning of muscle wasting, what doctors call cachexia. Instead of building up, the body consumes itself. If you're overweight, it'll take the fat stores first, but then it'll also start taking from your muscle. The very tissue meant to move us, protect us, and give us resilience becomes fuel for survival. So if you start getting muscle wasting, this is a huge red flag to change your diet too fast, to do whatever you have to do to get out of this vicious cycle. It is another way the microbiome is the linchpin in the cycle of illness. When it falters, this ripple spreads, not only to blood sugar, energy, and immunity, but to the very foundation of our strength, which is our muscles. And like I said before, it also affects nerves, kidneys, liver, cardiac, brain, you name it. It's a massive cascade effect. So a damaged gut and weak microbiome can contribute to muscle wasting and cachexia. So the gut-muscle axis, yes, that's actually a thing. The gut-muscle axis actually describes the complex biodirectional communication between your gut microbiome and your skeletal muscle, influencing muscle mass, quality, and function. The interaction occurs through metabolites like short-chain fatty acids, metabolites like bile acids, and immune signals such as cytokines, which can affect inflammation, energy metabolism, and insulin sensitivity in muscle tissue. This axis is also influenced by factors like exercise and diet, creating a system where muscle activity can alter the gut microbiome, and the gut microbiome in turn affects your muscle health. So there is a very strong biodirectional feedback loop here between your gut microbiome and your muscles. Healthy gut, healthy muscles. Unhealthy gut, unhealthy muscles. The gut microbiome helps regulate nutrient absorption, amino acid metabolism, and short-chain fatty acid production. Short-chain fatty acids, especially butyrate, protect muscle tissue by reducing inflammation and supporting mitochondrial energy. When the microbiome is weak, absorption of protein and key nutrients drop, like B vitamins, magnesium, zinc, and amino acids. Muscles don't get what they need to help maintain themselves. Now, chronic inflammation also contributes to muscle breakdown. So dysbiosis equals leaky gut equals immune activation. So constant inflammation increases cytokines like your tumor necrosis factor alpha and your interleukin 6, and these directly trigger muscle protein breakdown. In cachexia, seen in cancer, chronic infection, autoimmune diseases, or mast cell disorders, the body literally cannibalizes muscle for fuel because inflammation overrides normal energy balance. When it comes to blood sugar and energy, propionate and short-chain fatty acids normally help with gluconeogenesis, which helps provide steady glucose supply or sugar. Without this regulation, blood sugar swings and mitochondrial dysfunction make the body pull protein from muscle to make emergency glucose. So, a weak microbiome will result in poor nutrient absorption and increased gut permeability. Your inflammation goes up, your cytokines go up, your mitochondria becomes stressed, your protein breakdown goes up, so it's cannibalizing you, and muscle wasting and cachexia winds up becoming the result. So if you all of a sudden start dropping a massive amount of weight out of the blue, and also atrophy, at first it looks like atrophy, but then it doesn't stop. That is cachexia. So hear me on this. A damaged gut and dysbiosis can absolutely accelerate muscle wasting, especially if you have chronic activation of mast cells, your immune system, and inflammation, because it's burning too much. That's why protecting the microbiome is critical to chronic illness. It's not just about digestion. It's literally about preserving muscle and preventing wasting, not to mention damage to the rest of your body. Cut out your triggers fast if you get to this point so you can rebuild. You must drop your cytokine responses before you can heal your gut. The microbiome isn't just about digestion, it is the silent guardian of your strength. So this is why a proper microbiome is essential for your protein breakdown and amino acid metabolism. All right, lipid metabolism, vitamin synthesis, and the interaction with your immune system. So your digestion and microbiome work very closely with all of these. The gut microbiome plays a central role in macronutrient metabolism. Beyond carbohydrates and protein, it also contributes to lipid digestion. Gut bacteria hydrolyze triglycerides into free fatty acids and monoglycerides, which are then absorbed by the intestinal mucosa. Bile acids, synthesized by the liver and secreted into the gut, are essential for lipid emulsification and absorption. The microbiome modifies these bile acids through deconjugation and dehydroxylation, altering their reabsorption and recycling via the enterohepatic circulation. And remember, we talked about this earlier. Your microbiome helps recycle your bile acids so that the next time you eat, you have enough for digestion and to help keep your intestinal tract clean and clear. Okay, just to help you understand this a little bit better, when it comes to fats, the gut microbes team up with bile acids from the liver and gallbladder to break down triglycerides into free fatty acids. These can be absorbed and used for energy, but the microbiome can also modify these bile acids, which plays a big role in cholesterol balance, fat absorption, and even energy regulation. This bile acid mechanism is critical for regulating cholesterol homeostasis, lipid absorption, and energy balance. The microbiome is also a key source of vitamins, otherwise not produced in sufficient quantities by the host. Gut bacteria synthesize vitamin K for clotting and bone metabolism, and B vitamins such as B12, cobalamin, B7, biotin, and B9, folate are crucial for energy metabolism, DNA synthesis, and cell growth. In terms of immunity, the microbiome exerts profound influence on immune cell development and homeostasis. Short-chain fatty acids produced by bacterial fermentation enhance regulatory T cell populations, modulating inflammatory cascades and providing protection against both pathogens and autoimmune activation. Through these pathways, lipid metabolism, vitamin synthesis, and immune regulation, the microbiome is not simply a digestive partner, but an active metabolic and immunological organ. Its dysfunction creates ripple effects that reinforce the cycle of illness. Okay, microbiome and digestion. How does this all fit into the cycle of illness? We're going to take an integrated snapshot of how this all fits together because the body is integrated. It is not compartmentalized like current medicine has made it. So this slide pulls together the pieces to show how methylation, BH4, and stress and your bile acids fit into the cycle of illness. On the methylation side, MTHFR variants reduce the ability to make active folate. That lowers SAMe, the universal methyl donor. And without enough SAMe, bile acids aren't conjugated properly, toxins accumulate, and the liver and gallbladder come under stress. Because SAMe is extremely important for detox, neurotransmitters, and your bile acid in the liver. BH4 is also critical. It is needed for enzymes that make nitric oxide and neurotransmitters. If BH4 runs low, nitric oxide synthase, that's your NOS gene, becomes uncoupled. Instead of making nitric oxide, it makes superoxides. And we've already talked about this in earlier videos. It's a damaging free radical and it oxidizes the body, and that is bad for the health. This drives oxidative stress and damages your mitochondria. Now add stress and cortisol signals the liver, the gallbladder, and pancreas to go into fight or flight mode, raising blood sugar and straining the microbiome. Chronic stress increases the demand for BH4 and worsens this whole imbalance. And if you've got the MTHFR 1298 on top of it, it's already going to be hampered. Meanwhile, bile acids act as a signaling molecule, not just as digestive aids. In dysbiosis, their composition changes. That drives inflammation, mitochondrial stress, and neurological effects like brain fog or mood shifts. Now, normally bile acids cycle back through the liver for reuse. That's that enterohepatic circulation we were talking about earlier. But if recycling is impaired by methylation defects, dysbiosis, or gallbladder problems, toxic bile acids are going to build up in your body. These spill into the liver, the gut lining, and even fat tissue, worsening inflammation and systemic stress. So, the big picture is this: weak methylation capacity plus BH4 depletion plus stress plus disrupted bile acids all converge into one hidden pivot of illness. And this is exactly why patients can feel like they're failing detox or burning out even when they're doing everything right. Alright, so MTHFR is already hampering your methylation. Let's look at the box on the left that says low methylation capacity. This is going to affect your bile acids, and they're not going to work properly. And in turn, toxic intermediates are going to accumulate. So toxins are accumulating in your body. And then in turn, this is going to put more stress on your liver and on your gallbladder. So MTHFR, along with COMT, BHMT, the MAT1A, the NOS, and methylation defects are big contributors to the liver gallbladder impairment. But they aren't the only ones. Toxins, infections, inflammation, and structural issues also plays a role. And things like when it comes to structural issues, it could be a birth defect, or you could have non-alcoholic fatty liver or a damaged liver. MTHFR also makes the 5-MTHF, which is that active folate. It is critical not only for methylation, but also for making more BH4. So you need this BH4 in order to make all this happen. So BH4 is a cofactor for NOS, that's the NOS gene, which makes nitric oxide. Tyrosine hydroxylase, that's the precursor to dopamine and norepinephrine synthase, and then tryptophan hydroxylase, which is serotonin, okay? Now, if your BH4 is running too low, NOS becomes uncoupled. So instead of making nitric oxide, which is a good signaling molecule and detoxifier, it makes superoxides. So like we said, this damages the body. It's oxidative stress. It also damages your mitochondria, and you need mitochondria to create energy for your body for your daily energy needs every single day. Without mitochondria, we cannot live. Now, stress, cortisol, and the gut, liver, pancreas axis. Cortisol, that goes up automatically when your body is under stress, whether it be physical or mental or health related. Cortisol signals the liver, the gallbladder, and the pancreas to mobilize resources for fight or flight. So, stress is going to drive up your cortisol levels. This is going to change your bile flow. This is also going to raise those blood sugar levels. Remember, we were talking about gluconeogenesis. This is going to raise that. So your body is going to be pumping out more sugar. This is where also, if you're pumping out more sugar, if you don't have enough carbs or you're fasting, etc., this is where you can get stuck in that negative feedback loop with the muscle wasting, because your body starts cannibalizing the fat and the muscle in your body to keep going. Now, chronic stress equals chronic bile and pancreatic enzyme disruption. Many people have to use pancreatine or some other digestive aid in order to eat. This is going to also
result in maldigestion of fats and proteins. And as we talked about in the protein section, anything that does not get broken down properly and makes it into the large intestines, if you have a leaky gut, it's going to leak out and it's going to cause immune reactions. It's also going to ferment in the large intestine, which raises your ammonia levels. And all of this affects your ability to detox that ammonia. And that's going to cause a lot of health issues, neurological, brain fog, migraines, muscle pain, etc. Now, because this is happening, this is going to put a lot more strain on your microbiome. You would be amazed how stress affects your microbiome. It can crash it. So, chronic stress, cortisol, and inflammation increase demand for BH4. Do you know what else increases demand for BH4? Caffeine. Because caffeine is burning through your nutrients, it's burning through your cofactors, etc. that helps keep recycling BH4. Plus, it's an oxidative stress because it's full of oxalates that also burns through your BH4 and turns it toxic. Okay? If you have COMT, the warrior or worrier gene, and I'm talking more on the warrior side, the one where you're irritable, etc., I call it the Hulk gene, that is also going to have a huge impact on your BH4 because that means your body's making a lot of adrenaline. A lot of adrenaline is a stress on your body and it keeps you stuck in fight or flight. So this will also play a huge role in this. Cytokines, especially interferon gamma and tumor necrosis alpha, upregulate the NOS gene, which consumes BH4 faster. Now, if you remember in methylation, we have talked about these genes extensively, and we need the NOS gene in order to have the BH4 work properly, and so that it doesn't cause neuroimmune issues, migraines, etc., and neurological issues. Without enough recycling via the MTHFR and the folate cycle, BH4 will become depleted. And too much oxidation, not enough folate, caffeine, also chews through BH4 and creates more oxidative stress, which alters the microbiome and your mitochondria, and in turn, more methylation impairments, which also means more damage to the microbiome. MTHFR indirectly affects the NOS function. So stress, immune activation, which is chronic, accelerates your BH4 drain. When BH4 is gone, NOS is going to flip from a signaling healing enzyme to a toxin factory. And this worsens your inflammation, your mito damage, and your detox impairment. So stuff like ammonia is going to build up in your system. And this is also going to cause a lot of neurological, brain fog, etc. type symptoms. This is one of those hidden pivots in the cycle of illness. Patients stuck here
can look like they're failing detox or burning out, even when they're doing everything right. And part of this is part of that cachexia, but at the same time, that whole stress response keeps you stuck. Bile acids as messengers. Bile acids aren't just for digestion, they're also signaling molecules. They interact with the receptors in the liver, pancreas, adipose tissue, muscle, and even the brain. Some of you may know these receptors as the FXR and the TGR5 receptors. In stress or dysbiosis, bile acid composition changes. The toxic bile acids climb, and this will result in inflammation, mitochondrial stress, and neurological events, such as brain fog, mood shifts, neurological symptoms, etc. The enterohepatic circulation. If you remember, this is where your bile acid gets recycled. Normally, bile acids are secreted into the gut. They help digest fats, and then most are reabsorbed back into the ileum, that's part of your lining to your intestines, and returned to the liver for recycling. If bile acid recycling is impaired, and that can happen because of methylation issues, dysbiosis, and liver and gallbladder problems, toxic bile acid builds up. And this can result in liver pain and gallbladder pain.
And then this can also cause damage to the liver and your gut lining. So some of you may have non-alcoholic fatty liver, and if you're already feeling pain and you don't change your habits or your diet, you can wind up actually damaging the liver and the gut lining further. The good news is the liver has an amazing capability to heal, but in order to do that, it requires you to take the necessary steps. The body will generally try to move toxins into white adipose tissue or that belly fat, and it acts as a storage unit to protect your vital organs. Another reason people struggle with weight, neurological issues, or why some need pancreatine support. Because remember, the more white adipose tissue or harmful belly fat that you acquire, it starts acting like a endocrine organ, and it alters hormones, but it also tells the body to make even more inflammation. If you've been watching my videos so far, you know what this means. How is it all connected? Okay, bile acids themselves are both digestive tools and inflammatory messengers, so their imbalance creates system-wide effects, not just gallbladder pain or fat malabsorption. So there is an integrated pathway, and it starts with the MTHFR gene mutation. It converts folate into 5-MTHF, which is needed for homocysteine, methionine, and turns it into SAMe. SAMe is the master methylation donor, which drives methylation. It helps it to detox, DNA repair, neurotransmitters, bile acid conjugation, and also recycling. Methylation's downstream roles winds up with the liver and gallbladder. SAMe conjugates the bile acids and creates safe fat digestion and recycling, like we've been saying. The detox pathways, SAMe and glutathione, that's your body's master detoxifier, handle the toxins, hormones, and medications. Neurotransmitters, SAMe and COMT, regulate dopamine, norepinephrine, and estrogen levels. Now, the BHMT gene and the MAT1 gene are backup methylation routes, but are also tied to SAMe. Now, for those who have the BHMT gene mutation, you have to be careful, because if you try to take betaine, which is also called trimethylglycine or TMG, that pathway can wind up being blocked. Yes, it can help give you extra methyl, but if that pathway is blocked, it could wind up causing more harm than good. Alright, so the MTHFR intersects with BH4, and so does the microbiome and the bile acids. The 5-MTHF from MTHFR are also needed to recycle and regenerate BH4. BH4 is a cofactor for NOS, that's that NOS gene in methylation, which is nitric oxide synthase. It is also needed for dopamine and norepinephrine synthase. If it's not working properly, or you don't have enough vitamin D, as well as having the COMT gene mutation, which we call the Hulk gene as a nickname, you're going to wind up making a whole lot of adrenaline, and it's going to make you very irritable and raise your stress responses tenfold. Now, I know some of this is sounding very repetitious, but what I'm trying to do is tackle it from multiple angles so that you can see the intricate relationship that they all have with each other. If you are not familiar with methylation, and that's what all of this is talking about right now, please review the methylation slides, the genes and SNP slides, or the master methylation video, where I go in great detail on how the methylation works, how all the genes talk to each other, and what happens and how to fix it. Alright, so BH4 is also needed for serotonin. If BH4 depletes, NOS uncouples, and this is going to make superoxide and peroxynitrate. That is oxidative stress. And if you remember in the methylation videos, this is the stuff that causes brain damage, neural damage, and activates your neuroimmune system. And it can result in neurological illnesses. It also, if the BH4 depletes, your neurotransmitter production will fail. immune system activation will escalate because of the fact that you're making more oxidative stress to the body, and it's going to keep your body stuck with your immune system constantly kicking in. Stress does the exact same thing, whether it's stress in your life, stress mentally, or stress from eating, breathing, etc., something physical due to diet, pollution, whatever the case may be. Now, there is a spiral that takes place. So this is where it kind of can spiral out of control. The spiral will result in the MTHFR impairment, which causes low SAMe. And for the low SAMe, this is the MTHFR 1298 Charlie that I'm specifically talking about. It flips on SAM, so you're going to have lower SAMe. The lower your SAMe, the lower your BH4. Add in stress, caffeine, bad diet, that's going to cause a whole lot more problems and burn through your BH4 even faster. Your liver gallbladder plus bile acid conjugation is going to wind up failing. So you're going to find yourself needing digestive supports to eat. You could wind up eventually even having your gut shut down. Your detoxification is going to stall because you don't have what you need to keep your body detoxing at the level that it needs to be detoxing. So that's a lot of times why I tell people they need to fast, because your body needs time to detox. NOS uncoupling, as we said, causes oxidative stress, and then that winds up damaging your mitochondria. And you know that these are all core functions of the cycle of illness. The immune system is going to ramp up, and that is going to cause chronic stress, and cytokines are going to drain your BH4 even further because your immune system, your stress levels to your body are just climbing. The cycle is going to worsen. It's just going to keep getting worse and worse and worse until you break it. And this is going to lead to inflammation, metabolic chaos, mast cell activation, and eventually cachexia if it is left unresolved. So the cycle would look like this. Step 1, MTHFR. Step 2, weak bile. Step 3, enterohepatic spillover, which means it's not working properly. Step 4, your microbiome is going to wind up getting inflamed. And step 5, you can wind up with cachexia and MCAS. Now, the MTHFR methylation impairment, weak bile acid conjugation. Toxic bile builds up. Stress and immune responses and diet worsen it, driving your cortisol up. The enterohepatic circulation winds up getting disrupted, so then you have to take digestive aids. There's going to be a toxic spillover into your brain, and it's also going to create more belly fat to bind up all those toxins so that it doesn't hurt your body until given a time when it can actually deal with it to keep you out of crisis mode. Then your pancreas, liver, and gallbladder are going to get overloaded. This is all just spiraling out of control. Then malabsorption or maldigestion. So you're not getting the nutrients that you need, or your gut could wind up shutting down. Then your microbiome winds up becoming depleted, and you wind up with more allergies, more trigger foods, etc. And then you can wind up with dysbiosis, because if the gallbladder isn't working properly, the gallbladder is what cleans your intestinal tract. It prevents parasites, it prevents SIBO, it prevents candida, and etc. from building up in the system. And if it's not working, you're at a much higher risk of those conditions developing. And then it just keeps going in a vicious cycle. Okay, so this again is basically repeating the same thing I just said. It's just a side-by-side comparison between MTHFR and methylation and the MTHFR and the BH4, meaning you're running out of BH4. They are basically identical. However, based on the two charts, there are very slight variances based on the BH4 being affected versus the BH4 not being affected. So I'm not going to go and reread this all over again, but if you want to stop, pause the video, and take a look at it, please help yourself. The next video will be out shortly, and that is going to be salicylates and oxalates. but salicylates and oxalates from the standpoint of how it fits into the cycle of illness. I have other videos and papers on salicylates and oxalates, and I also go into it in great detail in the methylation videos. Now, if you'll excuse me, my little 2.5-pound tiny tot supervisor with mast cell disorder that is just as bad as the rest of ours is demanding cuddle time and her bedtime. It's late and she is demanding bedtime. She's so spoiled, but I wouldn't have it any other way. She's waiting for me to curl up with her in bed. But her new nickname is the Masto Mascot.